bus impedance matrix. Formulation of, you just take on formulation of bus impedance matrix by using the bus building algorithm. Bus building algorithm. Okay, bus building algorithm. So I think in many exams. Okay, so with this, without this algorithm and without this problems, might be none of the question paper you can see. Okay, so because formulation of the bus impedance matrix by bus building algorithm is one of the very important topic in power system analysis or power system computation methods in power system or computer methods in power system. The all this subject, this particular bus building algorithm is very important. So what are the main advantages of this bus building algorithm are any modification of the network does not require complete rebuilding of the ZBus. So say for example, any modification, say for example, you are adding any bus, okay, it does not require complete rebuilding of the ZBus. Whereas in some other case, if you are not following this particular bus building algorithm, then what we need to do is you need to redo this, say for example, any addition is there, any bus newly adding. Okay, so due to the demand, some new buses coming inside. So if you are going with the old techniques, okay, definitely you need to redo the whole calculation. Say for example, it is 40 cross bus, 40 bus, okay, 40 cross 40 matrix, okay, 40 bus system. Okay, there it is very difficult. Whereas the two bus system you can easily do with the calculation. Okay, so that is easy. But if you imagine it is 40 cross 40 matrix, so again you need to start from the scratch and you need to complete. Definitely it might take 4 or 5 years to complete, maybe more than that also. It depends on the values, impedance values, practical impedance values. Definitely it will take more time. Okay, so more time. So for that, only this algorithm, that is bus building algorithm, has more advantages. Advantages so that any modification, if you want to do in the network, does not require complete rebuilding of the ZBus and easily computerized, because this is in algorithm format. No, so if you just program it in MATLAB or whichever the software you want, even in Python also you can program, or if you know only C programming, you can program it. Okay, whichever the program platform nowadays, even in Java programming. So nowadays algorithm is important. Okay, platform is secondary. Okay, platform, any platform you can choose. Python programming also you can choose for calculating this. But only thing is that some specified rule should be there. Rule means algorithm, set of procedural rules. Procedural rules is algorithm. So this is the procedural rules or algorithm for the bus formation of bus impedance matrix by using bus building algorithm. Okay, that is the bus building algorithm. So take on this. Assume the original buses with the n nodes. It is proposed to add new elements one at a time to the network and get modified ZBus matrix in the following 4 ways. What is the first modification we need to do? First, you need to add a first element. Okay, whichever the element you are taking as a first element, you add the element with the impedance Z connected between the reference node and the new node. Add the element with the impedance Z connected between the reference node and the new node. Next, what is the modification to add an element connected between the existing node and the new node? So already something is there now. Say for example, this is the first element you are taking. This is the reference node. This is the first element you take. So again, say for example, another one element will be there. Okay, another one element will be there here. So again, what you need to do is you need to take the another one element here and you need to calculate the new ZBus for that. Okay, so that is what this is the modification. Add the element to the connected existing node I and make the new node n plus 1. So what is the modification 3? This is the glimpse of the this algorithm. Add an element connected between the existing node I and the reference node. Okay, so that you need to do. Next, what is the modification number 4? Add an element connected between the existing node I and J. Okay, so these are the 4 modifications you need to do. Okay, add an element connected between the existing node I and J. Okay, so what is the rule number one? First, what is the rule number one is add an element with the impedance Z. Okay, say for example, as I said, add an element with impedance Z connected between the reference node and the new node. So say for example, this is the new node, this is the reference node. So you take a new element Z, okay? You take a element which is existing that you need to, okay, take here this node as new node, that is n plus 1, that is shown in the figure. Okay, that is what they said. Add an element with the impedance Z. Okay, connected between the reference node. This is the reference node and this is the new node as shown in the figure. Next step, consider an impedance Z connected between the reference node and the new node. Consider an impedance Z connected between the reference node and the new node. The addition of the bus will increase the order of the matrix, order of the bus impedance matrix by 1. Okay, say for example, one new element is connected now, the order will be increased to 1. Say for example, so first thing is 1 cross 1 matrix is there. Suppose one more element you are adding. So now the element, the order of the matrix becomes one more. Okay, so now the modified Zbus becomes 2 cross 2 matrix like that. Understood? No? So like this, say for example, Zbus mu is equal to some 2 cross 2 matrix. Okay, 2 cross 2. Okay, so here Zbus old. What are the old values here you need to add, and here is 0, and here whatever the Z. Okay, that you need to write. Or that is the new. So say for example, here only one element is there. So this 2 are 0. This also no element because only one element is there. So simply Z, whatever the Z. Say for example, Z value is 3 plus 4J. For example, I'm telling 3 plus 4J is the impedance here. So simply you can frame the new bus as 3 plus 4J. Here is 0, 0. That is no need to take care. And also here Z. So no element also there. So this also becomes 0. So only 1 cross 1 matrix will come. Okay, but general formulation this is, but here only 1 cross 1 matrix is come. Next, rule number 2. Add an element with the impedance Z connected between the existing node I and the new node n plus 1 as shown in the figure. This figure. So now again you are adding the new impedance Z between the existing node and new node n plus 1. Again new node. This is the again new node. Okay, some other new node. Okay, so again, what you are doing is you are adding the new element. Say, for example, this is Z. This is some Z1 or something you can make it because to make the difference. Okay, Z1 like that you make. Okay, so here you are taking this Z. So consider that impedance Z that is connected between the existing node I and the new node n plus 1. Okay, so the addition of bus will increase the order of the bus impedance matrix by 1. As I said, again, one more order you need to increase. Then the modified Zbus matrix is given like, so whatever the old bus, say for example, I said no, here old bus values 3 plus 4J, 3 plus 4J, you take it as it is here. Okay, so this node, this whatever the values come here, the same thing. Okay, say for example, this okay row. Okay, in this column, is some 3 plus 4J. So here also 3 plus 4J. Okay, so in this row 3 plus 4J is there. So here also 3 plus 4J. Okay, so here only one element is there. If you transpose also, same will come. So here also 3 plus 4J. Okay, understood. So here, whatever the new element you are adding, okay, this plus this new element, okay, new element Z plus whatever the old that, say for example, here 3 plus 4J I said, no. So here some values, say for example, 1J. So 1J plus 3 plus 4J. So that is the matrix here, where Zi is the ith column of Zbus and Zi transpose the transpose of Z. So here, whatever is the value there, just you make it transpose because it is 1 cross 1 matrix. So if you make transpose also, the same values will come. So same thing you can take. Okay, in the problem you can see correctly. Okay, now don't confuse. if we solve the problems, then you can make it very clear. Okay. So now you take down the general formulation alone. Next, while coming to the problem, you can understand very easily than the algorithm. Okay, but this is the general algorithm. Okay. Okay. Next, now how to formulate the new bus means yeah, like this. So Z bus equal to Z bus. So Z bus old. So here, whatever the say for example, whatever the values here it is there, that you need to write. Say for example, Z1I, Z2I, Z up to Zni, and here also that same matrix in transpose. Okay, whatever the values coming here in transpose. So in transpose you need to write. So that's what it is written like this: Zi1, Zi2, is up to Zni. Okay, so this is as I said. So whatever the new values, this plus this. So whatever the values here, okay. So that is y Z11. That Z11 plus whatever the new values you are adding here. Okay, so that is the. What is the rule number 3? Add an element with the impedance Z connected between the existing node I and the reference node as shown in the figure 4.3. Now, again, a new element is added. Okay, new impedances, that is element is added. So now what we need to do is, say for example, new element is added. Now it is say for example, it is 2x2 matrix up to previous thing. Now again, one more element is added. So let us assume that and the first step is to add the element between the existing node I and the fictitious node n plus 1. Okay, n plus 1. Obtain the modified Z bus matrix of dimension n plus 1 into n plus 1 matrix by using the matrix 4.4. Okay, n plus 1 into n plus 1. Okay, say for example, if it is 3 bus, so while forming, it will become by using the fictitious node. Okay, so it will become 4 cross 4. But you need to reduce that into 3 cross 3. 4 cross 4 to 3 cross 3. So what is the second step? Second step is to connect the fictitious node, yeah, n plus 1 by the zero impedance link source reference node whose okay, voltage is 0, that we know. Now, to obtain the modified Z bus, we need to reduce by using the Kron's reduction formula. Where Kron's reduction formula we have seen, Kron's reduction formula we have seen in the last class. If you just have doubts, you go back to my previous class and you just clarify what is Kron's reduction method, how to frame the Kron's reduction method, what is the formula for calculating the Kron's reduction method. There I have explained. You just go back to the previous class. So here, what is the general formula for using the Kron's reduction formula is Z jk m whole power m bus is equal to Z jk minus Z j into n plus 1 Z n plus 1 into k divided by whole divided by n plus 1 into n plus 1. Okay, this is the formula for calculating the Kron's reduction method. Okay, say for example, n is 1. Okay, so n is 1, n plus 1. So sorry, n is 3. So 3 plus 1 is 4. So 4 Z4 will come here. So here also n is 3 means plus 1. So 4, J4. Okay, 4 K. Like that it will come here. Okay, here the size of matrix will not change because no new node added. Next, again, after this, again a new element is added means. So what we need to do is, so we need to do with this formulation. Again, new node is again add an element with the impedance Z connected between the I and J as shown in the figure. Now what we need to do is, so whatever the matrix come over here, say for example, it is 3 cross 3 matrix. Okay, so here column J minus column I. Okay, so whatever the column here coming, that you need to write here, and the column J minus row J row I. So here whatever the matrix coming, say for example 3 cross 3, you know, that you need to transpose and write here. Okay, so here column matrix simply you need to write here without transpose. With this transpose row matrix, you need to write here. And one more formula for, okay, this you need to remember. Z plus Zii plus Zjj minus 2 into Zij. Okay, this formula is very, very important. Rule number 4. So many problems will stop here only. Many problems, say for example, after reduction, it will stop. Say for example, it is 4 cross 4 matrix. If you need to reduce 3 cross 3 matrix, many problem will stop up to rule number 3. Say for example, some rare case if the buses are more. Say for five buses are there, 6 buses are there. In that case, we need to go for this rule number 4. So, okay, so here you need to remember column j minus column I, row j minus row I, sorry, column not minus, column j to column I, row j to column row I. So here, this you need to calculate. This is not just a new element plus new element like, but here new element is z plus zii plus zjj minus 2 into zij. Okay, this you need to remember. Okay, after reduction, if any other element is there, then you need to go with this path. Okay, now the size of matrix becomes n plus 1 into n plus 1. To obtain the new modified Z plus matrix of dimension n cross n by applying Kron's reduction to the last row and column using this relation. Okay, so again, for say for example, if it is some 4 cross 4 matrix, again you need to reduce the 3 cross 3 matrix. How? By using the Kron's reduction method. This is the formula. Z jk of m bus is equal to Z jk minus Z of j into n plus 1 into Z of n plus 1 into k divided by Z of n plus 1 into n plus 1. Okay, where j comma k is equal to 1 to 1 up to n. Okay, here the size of matrix will not change because no new node added after this. Okay, so this is the algorithm for okay bus impedance match. So there are 4 rules are there. 4 rules are there. So it depends on the problem. Rules might be changing. Sometimes up to second rule itself, if the simple problem is there, up to second rule, the problem will be completed. If somewhat some big burn, up to third rule, it may continue. If more buses are there, up to fourth rule, it will come. But maximum, at the maximum, by pen and paper, we can solve up to 5 buses or 6 buses like that. After that, also you can solve, but it will consume more time. Okay, consume more time, you can solve still. But that's why if you go for programming, just by giving the values, automatically the algorithm logic you program now. So you'll get the final answer like, okay, like that also you can do. But first for that, you don't need to go for a program first itself. First, we need to understand the algorithm. First, we need to solve some simple problems. 2 bus, 3 bus, 4 bus, 5 bus, like that. First, a simple problem we need to solve. Then after that, you can go for programming. Then in that case, that will be very easy for